Okay, so the previous video defined continuity at a point, and we're going to take off from that where we left there and now talk about continuity over an interval. Now let's look at the case of an open interval, a comma b. Now f is said to be continuous over the interval, open interval a comma b, if it is continuous at every point in the interval. Now let's look at this by means of an example. So the green line here is the function that's given to us. So this is say f. Now let's see what happens when we're in the interval, open interval, -7 to -5, which is right there. Of course, -7 to -5 would mean the interval doesn't include the two endpoints, but it's the set of all points between -7 and -5. Well, the function is defined. The limit is going to exist at any point. And if I approach the function from the left or from the right, it's going to be the same limit. And we can see from the graph that the functional value will be equal to the limit at any point in this interval between -7 and -5. So is the function continuous over that interval? Yes. Let's look at another example of -2 to 1. And you see how the function has a jump here at -2, comes down that way. It's defined at -2 there. And from after -2, it jumps down and then continues up until you get to 4. And then right after 4, it comes down that way. Now, is the function defined in the open interval between -2 and 1? Remember, because it's the open interval, we're talking about this portion. And at the point in that open interval, functional value is defined, the limits exist, and the limits will be equal to the functional value at whichever point you're interested in the open interval. So is the function continuous there? Yes. Also note that in each of these cases, I was able to draw the interval without lifting my pen from the paper. So it is continuous in those intervals. Now let's look at the interval between 3 and 5. Well, when I'm drawing the function, I go up that way, I jump, and then I come down again. So there's a jump. So it's discontinuous at any point between these two, between 3 and 5. And also note that the left-hand limit approaches infinity, right-hand limit approaches infinity, and when they approach infinity, technically it's not a limit because the limit is only defined when it approaches a real number. So is the function defined in that interval? Is it continuous in this open interval? No. Well, there's a little more nuance when it comes to talking about continuity at a closed interval. So the closed interval is going to include the open interval between these 2 points as well as the 2 endpoints. So how do you define continuity over a closed interval? Well, the function now needs to be continuous at every point in the open interval between those 2 points. And it also needs to be continuous at the endpoints. And how do you define continuity at endpoints? If A is the lower limit or the left-hand side, when you approach the right-hand side limit at A needs to be equal to the functional value at A, and the left-hand limit at B needs to be equal to the functional value at B. And that's how you define continuity at the 2 endpoints. Now let's look at these same intervals and see if they are continuous in these endpoints. So we have the function from -7 to -5. So we know they are defined in the open interval. How about the closed intervals? Is the left-hand limit at -7 equal to the functional value of -7? Yes. Is the right-hand limit at -5 equal to the functional value of -5? Yes. So therefore, the function is continuous in this open interval. From -2 to 1, remember we're moving from here to here and then drawing the line. So this is a closed interval, so I include -2 and I include +1. So remember, see how there is a jump when I draw the function, so we can immediately begin to see there is discontinuity. Now, what about the left-hand limit at x is equal to 2? Well, the left-hand limit is going to be -2 and that is not equal to the functional value of 2. Whereas the right-hand limit at 1 is going to be, the right-hand limit at 2 is not functional value of 2, whereas the left-hand limit at 1 is the functional value of 1. So at one of the points, endpoints, the function is not continuous. So therefore, it is not continuous in this interval. And when we talk about the case of -3 to 5, we saw that it is discontinuous even in the open interval. So by default, we know that the answer is that it's not going to be continuous in the closed interval as well. So that's about continuity in open and closed intervals. Now, if we're talking about continuity over all real numbers, so the function is just going to be continuous across the entire real number line if you can just draw the function in one smooth fluid motion. So that would be a continuous function. Whereas if I want to draw something with breaks in it, so if I draw here and I stop here, and then I start here again and keep increasing and so on, and then stop there and jump again, this is discontinuous. If it has a jump or a break, it's discontinuous. If you can draw the function in a smooth fluid motion, it is continuous. And with that, we'll wrap with continuity. Good luck with everything.